Alright, good day. As you can see, what we have today is graphing radical function. Our subtopics will be based on three area of radical function. The first is graphing radical functions. Graphing radical functions. The second will be right transformation of radical function. Right transformation, of course, with examples. Right transformations of radical function. This is the second. And the third is graph parabolas and circles. Graph parabolas and circles. So this is the third thing we are going to do today. So let's start with a graphing radical function. Graphing radical functions. A radical function contains a radical expression with the independent variable in the radical. So in order to graph a radical function, there are a few things we have to know so that we can proceed. A radical function contains a radical expression with contain a radical expression with independent variable in the radical. So it contains a radical expression, contain a radical independent variable in the radical. When the radical is a square root, the function is called a square root function. When the radical is a cube root, the function is called cube root function. Alright, let's proceed on graphing a radical function. To graph a radical function, you have to know the root, the parent graph. From there, like what we did when we were treating graphing polynomial functions, it is the same here. There is no different. The only difference is the function is radical. It can be rational. So this is what we are going to do today. Parent function for square root and cube root function. Parent function for square root and cube root function. So we have the parent function for the family of a square root function is, I hope you are following. The parent function, I use abbreviation, for square root for the family. The parent function for the family square root function f of x is equal to the square root of x. This is the parent function for the family of square root. You have to know this. So So it's just like this. Let me make it very short. We are talking of the parents function. So for the square root, we have f of x is equals to square root of x. This is for square root. The parents function for square root. The parents function for cube root, f of x is equals to cube root of 3, cube root of x. So I hope you are following. We are under graphing a radical function. So first you have to know the parents functions. From there you can derive other functions related to its parents or its foundation. So for the graph of square root, here is 1, here is 2, here is 1, here is 2, this is y I z, and here is x I 6. So let's say we have minus 1 here, minus 2 here, minus 2 is 0. So if we have something, I hope you're following. So minus 1, minus 2. So the graph of the graph will look like this. We start from the origin. This is f of x equals to the square root of x. And if 1 goes like this, if 1 is here, let's say here is 1, here is 2, this will go like this. Just until it touches the graph, you bring it down. So here it may be 1, here is 2. So this is the graph of f of s equals to the square root of x for the square root. And also we have for the cube. The cube will look like this. I hope you are following. It will look like this. Here is y I 6, here is x I 6, here is 1, minus 1, minus 2. So if you have the graph will look like this. This is how the graphs will look like. I hope you are following, because it's cube. It will look like this, pass through the origin. All the parents has to pass through the origin at 0, 0. Here at 0, 0, when y is 0 and when s is 0. Here is 1, here is 2. So this is how it is. At 1 and 1 we have intercept at 1 and 1. It is at 2 you have another intercept. So this is how the graph of a cube. In this case we have the function. This is for the cube and this for the square root. So this is how the graph, parents graph of square root and the cube root looks like. We can now proceed. You see that the cube looks like as it has two turning points. Started from the origin. In this case it is closed and then open. While the square looks like a closed, just a curved line, a curve. So this is the parents. So this is possible. The domain of this is s is greater than or equal to 0. So if you look at here, you see that at this point s is greater than or equal to 0. It can start from 0 to move. See the values of x. It it will continue in this way, not here. So the range this range is y less than or equal to 0. So domain defined on the x-axis and the range defined on the y-axis. The range is y greater than or equal to 0. So in this area, y is greater than or equal to 0, this point. So at this point, for the range, y is greater than or equal to 0. This graph holds for even or even. This graph you see will hold for all even and net root. If you plot a graph of, let's say, f4 of x equals to 4, something like this. Here is 4. You see it look like this. For 6, you will see it looks exactly like this, no different. If you have a graphic calculator, you can check it. We suggest that the parent's graph will hold for all even and net root. It will hold for all even and net roots. I don't know if you understand it. So let me state it here. The graph or the condition or the graph hold for all even and net. The graph hold for all even and net roots and the condition the same, and as long as is from the parents. The condition, the range is s greater than or equal to 0, the domain is s greater than or equal to 0, or range y is greater than or equal to 0. But if there is minus here, this will flip in this way. So you have to consider other factors. In this case, y is less than 0. So let's look at this one. The domain is all real numbers. The domain is what? All real numbers. I abbreviated it, all real numbers. The range is also all real numbers. The domain is all real numbers and the range is also all real numbers. As the graph of even square root hold for even numbers, the same applicable to odd. This hold for what? Odd, or all odd and net root. The graph holds for all odd and net root. I hope you are seeing it. That is how it looks like. So this is the two definition. Always based on your foundation on these two definition, for even and for odd, to graph any given function of a radical function, for any given graph of a radical function. So let's give instances. For like we have the table of values for describing how the graph of a polynomial looks like and how to plot the graph. The same applicable to radical function. So I would have referred you to the table of polynomial, but let me do it here so that at once you can be able to follow up immediately from here rather than going through the textbook and so the first thing is to You can transform the graph of radical function in the same way you transform the graph of what functions previously. Sorry. So let's give a table of values for doing this. Function, transformation, function. This is function f of x. F of x. This is example. So in order to graph it, you have to know these things. They are not much different between them. The first is horizontal translation. Horizontal translation. Graph shift left or right. We have done this when we were doing polynomial function. So let me refer it. There's no more difference between them. The graph shift left or right. So f of x, it looks like this, as if it is a closed function. When we did the other one, when we are talking of horizontal translation, it's always a closed function, as we have seen. So you can be able to translate the h in the horizontal axis. So g is equals to the square root of x plus or minus 3. So from here you have 3 units down, three units up. So when you are 3 units down or 3 units up, no. So you have 3 units to the left, 3 units to the right, so when, for like this example, if it's plus, it goes to the left for plus, for minus h. If it's plus, it goes to the left. If it's minus, it moves to the right. For horizontal what? Translation. So the second is what? Vertical translation. We are talking of translation. You see, it is what exactly we did in the function, polynomial function. So I always refer to it to read, so that you can refresh what you did there and put little effort here for you to be able to solve questions when we come to that. So we have vertical translation, graph shift up or down, graph shift up or down. This is shift. So for vertical translation, the graph shift, you have seen it, graph shift up or down. The function is always a open function. F of x plus k, f of s plus k. So g of x is equals to the square root of x plus or minus 7. This is how the vertical translation look like. It move up or down, while the horizontal translation move left or right. For translation, not for stretch or shrink, for translation, the position changes. So if you have this, so when you have this type of a function, it means 7 unit up, 7 unit up, or 7 unit down, 7 unit up or 7 unit down. That is K. This is K. So for vertical word translation, then the next is so graph stretch away from or shrink towards y-axis. Horizontal stretch or shrink, graph stretch away from or shrink towards x-axis. F of ax, so this is how the horizontal stretch or shrink looks like. It's always a closed function. In this case, g of x, hope you are following, g of x is equals to root 3x, always a closed function. You cannot translate stretch or shrink. Applying the reciprocal rule when it is horizontal. Shrink by a factor of what? This will be shrink by a factor of 1 over 3. So you have another one, g of x is equals to square root of x over 3. This will do what? This will stretch away, stretch by a factor of 3, stretch by a factor of 3 units. So if it is in this form, stretch by a factor of 3 units, we have done that before. Find the reciprocal of it. It is like to know what happened in horizontal stretch when you see a closed function, just find the reciprocal 1 over 3. So it will shrink by 1 over 3. As you given this, we give 1 over 1 over 3. It will be 3. It will do what? It will stretch. This is applicable to horizontal stretch and shrink. So let's continue. So this is what we have done before. We are referring to it again, so to help you memorize what we did in the polynomial. There's no more difference between them. So let's continue. Vertical stretch shrink. For vertical stretch or shrink, graph stretches away from or shrink towards x-axis. Graph graph stretches away, stretch away from or shrink towards S axis so the function that defines this will be a dot f of x. So this is how it looks like. I hope you are following. In this case, g of x is equals to 5 the square root of x. This is an example how to define vertical stretch or shrink. It's always your open function multiplied by a constant. Stretch or shrink always attached to the highest variable, highest term in a given polynomial expression. So it will attach to the highest term, in this case 5 the square root of x. For closed function, you see it attached to the highest term. So we transform the stretch or shrink for vertical the same. So in this case we have stretched by a factor of 5 units. Stretched by a factor of 5 units. So if we have g of x is equals to 1 over 5 root x. I hope you are seeing it. So this will shrink by a factor of what? 1 over 5 units. So that is how it's supposed to be. So this defines vertical stretch and shrink. The next is reflection. Please, if it possible for you, if you have forgotten what we did in polynomial, please endeavor to memorize this table of value for transformation of radical function. Reflection graph flips over SI6. The graph flip over SI6 or YI6. The graph for reflection, if you are talking of reflection, the graph flips over SI6. So in this case, you will flip over SI6. So in this case, you have minus f of x. For example, g of x is equals to minus the square root of x. This is in the SI6. We flip over the SI6. So for YI6, I hope you are following. So for YI6, this is for SI6. For YI6, you have f minus x. What will happen? The reflection will flip over the YI6. The reflection will flip over the YI6. So in this case, g of x is equals to the square root of minus x. This is in the YI6. So this is all you need to know before we proceed. For reflection on the SI6, it is negative f of x. The function looks like this. Negative will come outside. This means it reflect, it flip over the SI6. For YI6, the negative is a function of x, so it's a close. it will flip on the y-axis. This is always possible for cube, odd numbers, and this is always possible for even numbers. So let's go into solving some problems. Memorize the table and then let's go into solving some problems. So I can now clean the board. Graph the function, identify the domains and the range of the function. Graph the function, identify the domain, and range of the function. So we now proceed. Graph the function and do what? Identify what? The domains and the what? The range of the given function. So the first thing is to do is to compare the given what was given to you with the parent's graph. From there you'll be able to graph it. The first is AG of x is equals to x squared plus 4. The first is what? The square root of x plus 4. You are required to do what? To graph the function, identify the domain and the range. We know that the parents graph will look like this. For the parents graph, we can do it. This is a square, so the parents graph will look like this. F4 of x is equals to the square root of x. So it will look like this. It is at 0, 0 that we draw this graph. So from here we can now draw the graph of AG of x. Since we are not told to use table of value, we can consider what was given to us. So from here we have 2, we have 4, here minus 1, minus 2, 0, 1, 2, minus 1, minus 2. So here AG of x is equal to square root of x, which is the parents, at the intercept of what? Plus 4. So it will start from here. This is where the intercept starts. It will look like this. This is the graph of AG of x. This is how it may look. So we know from 0, 0, if from 0, 0 AG of x is equal to square root of x, it will start here. But because we have learned how to describe and transform a given function, we know that the parents AG of x is a the graph of AG of x is a vertical translation by a factor of 4 units. That is all of the parent's graph of the parent's graph f of x. Do you understand? The graph of h of x is a vertical translation by a factor of 4 units of the parent's graph f of x. So just go up to the 4 and draw the parent's graph. So this is the graph of h of x. So can we continue? Once you be able to recognize that is a square root function or a graph of a square root radical function, you'll be able to plot it. So let's continue. Second question. Second example. If you are given g of x is equals to minus the square root of 2x. So you are required to graph the function. You can still maintain this. This is f of x. So you can draw it. This is y, this is x. If you look at it, the parents is the square root of x. That is how the parents look like. The square root of x. So it's the same. This is a closed function, as I have given you the table. These two here only define the stretch on the horizontal axis, that is by a factor of half. Negative suggests the reflection on the s axis. So from there we can, if you want to, we can make a table of value. Let's make a table of value. We can use our table of value to plot it. So make a table of value. You draw your table of values. So make a table of values and sketch the graph. Table of values. Here is x. Here is g of x. Because we can choose a whole number integer for x. You can say 0. You can start from 0, 0, 1, 2, 3, 4, and then find the g of x. You know how we did it before. When s is 0, g of x, g of 0 will be what? Minus the square root of 2 by 0. This gives us 0. So this is what we are required to do. So when s is 1, g of 1 is equals to minus the square root of 2 times 1. So use your calculator and find the, mind you are not looking for. So you have to get the you can use a calculator to find the square root of 2. Quickly use your calculator quickly. So let's from the calculator, the square root of 2 will give us 1.41 approximately. Mind you, there is negative 1.41. So you do the other one. When s is 2, if s is 2, g of 2 is minus the square root of 2 times 2. That gives us 4. So use your calculator to check negative the square root of 4. That will give us minus 2. So you check for s equals to 3. So g of 3 will give us minus the square root of 2 times 3 will give us 6. So you check the value of 6. That will give us what? Minus 2.45 minus 2.45 minus 2.45 minus 2.45. So you check s equals to what? 4. G of 4 will give us minus root 8. So check what root 8 is all about. That will give us minus 2.83. This is 83 minus 2.83. So with this we can now plot the graph. So you put the values of x 0, 1, 2, 3, 4, and then you may space it because all of them will fall on the negative. So here is minus 1, here is minus 2. So when s is 0, g of s is 0, that is at this point. When s is 1, g of s is 1.4. Let's assume it's somewhere here, negative 1.41. They will intercept at here. So when is 2, g of x will be minus 2. It will be here. So let me bring this up a bit because of limited space. So it will be here. I hope you are seeing it. So when g of s is 3, it will be negative 2.45. Let it be here, negative 2.45. It will be here. So, and finally, I hope you are seeing the table of value where I'm getting this point. When is this is 2, this is minus 2. Look at the table of value. When is 3, this is negative 2.45. They will meet here. So when it is negative 2.83, you draw it. They will meet here. So you use your ruler, use your curve. Use your curve and join it. So if you look at it, if you continue to give it value, it will curve. Continue giving maybe s5, 6, 7, it will curve. See how the graphs look like? So this is the graph of g of x equals to negative root 2x. This negative define is, this is not the, it's different from the parents graph. The negatives define reflection on the s-axis. The 2 here signifies a shrink. It's shrink by a factor of half because this is a closed function. If you look at the parents, the parents will look like this. The parents will look like this at 0, 0. We have done that before. So f of x is equal to the square root of x. So this is how the parents will look like. So it is in the opposite direction to this. If we put the parents here, you can now see it is a reflection on the exercise. Identify the domain and range of the function. So we can identify the domain. So what can you say about the domain? In this case, the domain is what? The radicand of a square root must be non-negative. The radicand of a square root must be what? Non-negative. That is, it cannot be -4. This is a radicand. This is a radical. This is a square root. Therefore, the radicand based on this theory, on this one, the radicand of a square root, the radicand of a square root must be positive. That is 4. Here is 2. This s must be positive, must be a natural number to obey the rule. The radicand of a of a square root cannot be what? Cannot be negative number. Therefore, the radicand of a square root must be non-negative. You can't get some. You can't get it here. You can still get something here, but based on the rule, the radicand of a square root must be what? Non-negative. I don't know where to write it, but the range. So the domain is what? S greater than or equal to 0. That is the domain, as we have seen from the parents. The domain S is greater than or equal to 0. All these values of S is greater than 0. If it is here, S will be less. So all these values, the domain is greater than what? 0. The range, I hope you are seeing it. The range y, the range is y less than or equal to 0. The range is y less than or equal to 0. Here is the range. This is for y. Here is for x. You are seeing it. This side domain is the x. Here is for y. If it's here, it will be what? Positive. But it's here. Therefore, y is less than or equal to 0. It's less. Here, the domain is what? The range is what? Y greater than or equal to 0. It's here. But for here, range is y less than or equal to 0. If I have a reflection here, domain will be x less than or equal to 0. But here we have, so therefore s is greater than or equal to 0 for domain, and the range y is greater than or equal to 0. But for this one, the range is what? Y less than or equal to 0. So we can now continue. All right. So let's do more examples so that you can be able to understand how to graph a radical function. So the third example, table of values is not needed. So third example, sorry. The third example, if you are given g of x is equals to 1 over 5 the square root of x minus 3. So graph this function. If you're looking at it, you see that for you to understand how to do it, you can describe the translation immediately with respect to the parents for you to understand it. This is f of x equal to the square root of x. It is at 0, 0. So with this you can be able to translate how the graph's going to look like. So from here you can say here is 1, here is 2, here is 3, here is minus 1, minus 2, this is 0, this is 1, 2, 3, minus 1, minus 2. So from here we proceed. The graph of G is horizontal translation by a factor of 3 units to the right. This function is similar to this function hg of x equals to c in bracket s minus h plus k. So it's similar to this. From here you can define how this graph looks like. Here our c is equals to 1 over 5. That is a vertical it's a vertical stretch by a factor of 1 over 5. While h minus h is equals to minus 3. Is it not? So minus can cancel out to give us h equals to 3. We suggest the graph will move to the right by 3 units. So you are seeing it, and k is equals to what? 0. Since we do not have vertical what? This is a vertical string. We do not have k. K is equals to what? 0 in this formula, in this function. So we have already gotten h. We already gotten what? H. H is equals to 3. So you go to 3 and do what? Plot the graph. So it will look like this. This is a function of g of x. This is what you are required to solve. Once you have done that, there's nothing left. You have already graph it. You can always use your graphing calculator to check how we arrive at these graphs. Sorry. So domain is x greater than or equal to 3. S is greater than or equal to 3. If you look at it from here, s is greater than or equal to 3 is the domain. It's only if s is greater than or equal to 0 when we start from the origin. S is greater than or equal to 3. This is where s begins. It didn't begin from the origin. Then R, the range. Our range is what? Y greater than or equal to what? 0. Y is what? Greater than or equal to 0 is the range. I hope you are understanding it. So let's do for cube. Let's do some examples of cube. So the fourth one, sorry. If you are given f of 1 of x is equals to the cube of what? Minus 5x. So here we've already done the parents of a cube radical function. The graph of the radical function for a cube is in this form. So it is in this form. In this case, f of s is equals to, this is how it looks like. In this case, started from 0, 0. So if it touches here, let's say from here, this is minus 1, you can bring it up, here is minus 1. So the intersect on this point will be minus 1, minus 1. So this is, if here is, let's say 1, and you come to this part, if here is 1, here will be 1. At this point, have 1 and 1. This is the parent's graph. So from here we can now plot the graph of f of 1. So let's go. Here is y. There is x. So because this is negative and it's a closed function, this graph will reflect on this side. The graph will look like this, because this is here. Because of this negative, the graph will open. Here is closed. So because of the negative, the graph, you can start here to graph it. So it looks like this. So this is how it's going to look. So are you seeing it? This is how it's going to look. This is f of 1 at 0, 0, because the parent is positive and is closed. So because of this negative, they all reflect, whether on this one reflect on the y-axis, while the square reflect on the x-axis, the cube flip on the y-axis. So it looks like this. This is how it's going to look, this graph. This 5 only define the horizontal shrink by a factor of 1 over 5, because it's a closed function. So it's horizontal shrink by a factor of 1 over 5, while the negative indicate the reflection in the y-axis. Reflection in a closed function is a reflection in the y-axis. So let's define the term. So the domain, because it's a cube, all real numbers will satisfy it. All real, and the range, all real numbers So this is how it's going to look like for this F1. Do you have any question before we proceed? Alright, let's do 5. That is the next question. Always pause the video, go through what we did. If you have any question, endeavor to ask me so I can provide the answer for you. So the next is Hg of what? Hg of x is equals to negative the fourth root of x. So number 5, Hg of x is equals to negative the fourth root of x. So how do you go about it? There's something I said about or even graph of a radical function and that of the or all the graph of radical function. For even, look at this, the parents is like this. F of x, always refer to the parents for clarity. That will enable you know how the graph looks like. This is square root, and this is fourth root. That is the multiples of 2. Negative only indicate the reflection in the I6. So this will look like this. It will look like this. That is how the graph will look like. This is how the graphs will look like. So always, if you look at the graph, it is easy for you. This suggests it's started from 0, 0, because there is no other constant or attachment. This also started from 0. So this is how it's going to look, the graph. With this, you can define the domain. The domain is x greater than or equal to 0. The domain x is greater than or equal to 0, because for all this side s is greater than 0. The range y is less than or equal to 0. Here y is greater than or equal to 0. Having learned how to easily plot a graph of radical function, let's go to the next thing we have today. The next is describe the transformation of f represented by g. We have used what they gave us to plot the graph. The next is to describe the transformation of the parents, the graph based on another function. Describe the transformation of f represented by g. Then graph each function. So describe the transformation of f represented by g, then graph each function. The first is f of x is equals to root x. G of x is equals to what? Root x plus 1 plus 8. So this is what we are given. This is the parents, and this is the transformation. Describe the transformation of f represented by g, then graph each function. So how do you, looking at the parents, the square root, there's plus 1 here, and there's plus 8. This look like g of x is equals to c, the square root of s minus h plus k, where c is what? Particle stretch or shrink. Minus h is what? Define the horizontal translation, and the k define the vertical translation. So from this we can compare minus h is equals to what? 1. So h is equals to minus 1, and k is equals to what? 8. So once we have known this, we can now describe the transformation. So g, therefore g is is a graph, the graph of horizontal translation is a graph of horizontal translation by a factor of 1 unit. It's a horizontal translation by a factor of 1 unit to the left, because this is negative, it will go to the left. 1 unit to the left. I hope you are following. By a factor of 1 unit to the left, and vertical translation by a factor of 8 units. Vertical translation by a factor of 8 units up the graph of f. So G is a graph of horizontal translation by a factor of 1 unit to the left, and vertical translation by a factor of 8 units up the graph of f. So once you have stated this, you can now go into what? Graphing the function. So we don't have enough space, therefore we have to clean the board in order to graph the function. So here, let's make some space. Then we have g of x plus 1 plus 8. So let me clean here. After graphing the graph, I return it. So let's graph it. So you can do the parents here. I hope you are following. This is the parents. This is alpha of x, the parents. So graphing this, here is 8, here is x, and here is 0. So here is minus 1, 1, minus 1. You know, I can call here minus 8. So this is how I put it. In this case, let's do it. So we can now horizontal translation to the left 1 unit, you come to here, and 8 you move up. Once you come here, you move up 8 units by a factor of 8 units up here. Then you can now graph it. The graph will look like this. You can always plot you can always use your calculator to confirm this. Graphic calculator. This is how the graph looks like. A horizontal translation 1 unit to the left. Here is the parents. I move 1 unit to the left, and then observe the another thing. What the other instruction? 8 unit up. I go up, and then I graph it. So this is how the graph looks like, or this is the graph. If a table of value is given, you may plot a accurate graph, but this is just a sketch. It's just to graph it. Have any question before we continue? All right, let's go for a second example. So the second example is a function f of s. You are given the cube root of f of x, and also given a function g of s, g of x is equals to minus this is x is minus 1. So you are required to describe the transformation, then graph each function. So from here you can now describe it. G is a graph of vertical translation. It's in this form. Always look at the form. Minus cube root of x is in this form. So if you look at this, you already know how to translate it. So from here we can now solve it. A is still 1 as the parents is 1. K is minus 1, which means down by a vertical translation, 1 unit down to the graph of the parents. So once you know other things to do, you can now describe the given function. Therefore G is a graph of vertical translation by a factor of 1 unit down, and by a factor of 1 unit down and a reflection in the exercises. So G is a graph of vertical translation by a factor of 1 unit down and a reflection in the exercises of the graph of f. So this is how you can translate the graph for yourself and be able to understand it. So you can draw the parents. This is the parents. The parents will look like this for the cube. This is equals to f of x. Okay, see, this is f of x. So sorry for, so here you can now follow the instruction. Here is 0, here is y, here is x. We have minus 1 here. So how do you draw this? You come to this point, because the parents here there is no negative, therefore this will become open first. You come to 1 and draw the graph. It will be open. This is how the graph going to look like. So the graph will look like this. This suggests a reflection. Look at the parents is closed and this is open. So this is the parents is cube root of x here, and the vertical translation down, you move 1 unit. Then there is a reflection. Instead of closing, it will open. So this is the graph of what? G of x. Do you have any question before we proceed? Alright, let's continue. This is the first example. The second example, sorry. Alright. So the third example, f of x is equals to the cube of x, as this is the parents function. F of x is equals to what? S raised to power 3. G of x is equals to 1 over 3 s raised to power 1 over 3 plus 6. So here you can now graph the function. Looking at this graph, you see that this is not like example 2 and 1. It's an open. So how do you define this? How do you define this kind of graph? A vertical shrink by a factor of 1 over 3 and a vertical translation. So looking at this, we can define it. G is a vertical shrink by a factor of 1 over 3 units, and vertical translation by a factor of 6 units. Vertical translation by a factor of 6 units up the graph of f. So it's a vertical shrink by a factor of 1 over 3 units and a vertical translation by a factor of 6 units up the graph of f. So you can plot it. The parents is here. Here is f of x. Here is 6. So you come to this and then plot it. So g of x, this is how it's going to look. This is the parents and this is the g of x. No, this is not exactly. This is for square. This is for the square. So from here, mind you, this is vertical. This is vertical. So from here, so the graph will look like this. This is h, this is g of x. So this is how it's going to look. If you plot the parents, it will look like this. So this is what is required of you. G is a vertical shrink by a factor of 1/3 units, vertical translation by a factor of 6 units up the graph of f. This is g of x, this is f of x. So let's continue. If I have any question, endeavor to ask. F of x is equals to the 40th root of x. So g of s is 2. So x plus 5 s plus 5 minus 4. Okay, see s2, the 40th root of s plus 5 minus 4. So the graph of g is a horizontal translation by f. It's a horizontal, the graph of g is a horizontal translation by a factor of 5 units to the left vertical stretch by a factor of 2 units. The graph of G is a vertical horizontal translation by a factor of 5 units to the left, vertical stretch by a factor of 2 units, and vertical translation by a factor of 4 units than the graph of f. The graph of G is a horizontal translation by a factor of 5 units to the left, a vertical stretch by a factor of 2 units, and vertical translation by a factor of 4 units than the graph of f. So we can plot it. So from here we plot it. Here is minus 4, here is 0, So from here we now we so from here we have here minus 5 is horizontal translation by a factor of 5 units to the left. You move 5 units here from the origin, move to the 5 and observe other 4 units down, you move to the 4, and then of the graph of the shrink will not affect it. So from here you now draw, you plot it. So this is so this is how it's going to look. This is how the graph is going to look. Since the parents will be from here, from the origin, the translation will be from here. This is the parents. So there's nothing again to do. Have any question? So do this once, please do them and send it to me. You see, there is no difference between what we did in polynomial function and what we are doing here. If there is just a subtlety, that very little. So do this. The first one, f of x g of x 1/4 minus x plus 6. So describe the transformation of f represented by g. This is the parents and this is what we will translate. Okay, let me do this one and then you can do the rest. Let me do this one. So f of s is the cube root of s squared plus 10, and the translation is g of s is 1/4 f of minus s plus 6. So we can start by saying the graph of g is a vertical shrink by a factor of 1/4 unit. The graph of g is a vertical shrink by a factor of what? 1/4, followed by a reflection in the y-axis, and vertical translation by a factor I hope you are seeing it. I'm trying to describe the transformation of G with respect to F. The graph of G is a vertical shrink by a factor of 1/4, followed by a reflection in the y-axis. There is a reflection on this graph. It's negative, suggests there is a reflection. A vertical translation by a factor of 6 units. Up of the graph of F. So once you explain it, the graph of G is a vertical shrink. See the shrink of 1/4 units, followed by a reflection in the y-axis, because it's a closed function. If it's here, if negative somewhere here, it will be in the x-axis, but because it is in the between the function, it is in the y-axis. Vertical translation by a factor of 6 units of the graph of F. So once you do the you stated it, you have already solved it. So if you plot the graph of the parents graph, I think the parents is supposed to be this question doesn't require you to plot the graph, this particular one, so you don't need the graph, and for that reason, please do these ones, do this. You have to plot the graph of these questions I'm giving you. So the first one is f of x is equals to the 50th root of x. I hope you are seeing it. The translation is g of x is equals to negative 32. Let me g of x is equals to negative 32x plus 3 for 1. The second is f of x is equals to negative the square root of s square minus 2 g of x is minus 2 f in bracket s plus 5. So this is the second one. The third is f of x is equals to 2 g of x is equals to f So these are 3 questions you are to solve. Do them and send to me exactly what I did. Describe the transformation of f represented by G. The second one, do not plot the graph here. No graph, but you can try plot the graph. For the second one, no graph, but first and third graph, we need graph here because it is what we did today, including the graph. So describe and also and plot the graph. Describe the transformation of f represented by g and then graph each function. There's 3 questions. Number 2, no graph. So let's continue. So graphing parabola and circles. Graphing parabolas. Horizontal axis of symmetry. Graphing parabolas, horizontal axis of symmetry. So I can clean it. Alright, we can now continue. So I can clean here. The graph of parabolas. Graph parabolas using a graphing calculator. To graph a parabola using a graphing calculator. To graph a parabola, using a graphing calculator, there are a few things you have to do. First, solve the equation for y to obtain radical function. First, solve their equation. Solve the equations for y to obtain radical functions. Then graph the function. Then graph the function. Example 1, parabola graph. I hope you are following. To graph a parabola using a graphing calculator, first solve the equation for y to obtain radical functions, then graph the function. So we are talking of parabola graph. So if you are given 1/4 y squared is equals to x, so solve for y. To solve for y, multiply both sides by 4 to clear 4, or cross multiply, you have y squared is equals to 4x. So find the square root of each side. Find the square root of each. Find the square root of each side. Find the square root of each side. You have y is plus or minus the square root of 4x. The square root of 4x. This gives us plus or minus 2 square root of x. So from here we have gotten that y is plus or minus